Hi guys, today we will try to perform synchronized averaging on a dataset which is provided over here. It's called big dataset. I currently have a dataset of EEG signals. So this basically, since my big dataset includes 64 rows and these many columns, I will be cutting it short to about 50 to 50. I will be cutting it short into 50 by 50 dimensional 2D matrix. To begin with, we will just create a section, and this section is for extracting dataset. So first of all, we will load our big dataset. I'll just press tab in order to automatically fill this statement. Once I have got the big dataset, I will declare a small dataset which I will initialize to all zeros. So I'm giving it a 50 into 50 dimension. Notice that I'm always using a semicolon. It is very important, otherwise you will get the entire statement as a command displayed on your command window. So once I have declared the size of small dataset, I will begin to extract using we can use two ways. So first I will show you how to extract using a for loop, which is for beginners. So we can write for I equal to from this range to around this range, for j equal to 1 to 50. I will store the value of each uh, I and j, which is the row and column respectively, of big data into small data. So the data is currently contained in this particular variable. It's called EEG data. So I will just input that over here. So now that I have written the command that I want to, I can just write end statements for my for loops. So once this is done, you can actually run this section and see what result you get. You can currently see the small data set in the command window. So this for loop is pretty unnecessary. Instead of this, we can actually just go ahead and write this statement, which is extract in one line, extract in one line. You can just write small data set is equal to EEG data from 1 to 50 rows and 1 to 50 columns. So this has the same effect as writing this for loop. Now we can just go ahead and continue our steps. So we need to subtract a baseline. So whenever we have a big data set, we should always take care to remove the uh, jitter to remove the jitter or small noise which might occur due to impedance in the experimental setup. So for that we can just remove jitter using baseline. So for us, baseline is actually the mean of first 10 columns. So I have chosen a baseline to be this way. It can be any other function. It is uh, totally up to you. So I will simply just write. So once we have correctly subtracted the baseline, we can go ahead and run our code. we see a stark difference between this new data set and the one that we had before, which is this. Now we can just go ahead and begin our template creation. So basically our template is the mean of every column, which will be, so the template design is basically the mean of every column. Um, what this basically does is it finds the mean value between all the for all the epochs. Every epoch signifies a new reading. Since this EEG data was collected in such a manner that every new row indicates a new stimuli recording, this template design will basically find the mean of every column, and that we can find from this of every column. So this particular code allows us to create a synchronized average of the entire data set. For a better visualization, I'll just write figure. Before that, let's comment it. Plot the synchronized average. Rich figure. You can name it something. Name syncav. Once I've done that, I'll just quickly write plot. So this particular time signal uh, is the mean template of all the 50 epochs that we had recorded. For a better visualization, I will probably just overlap the previous ones with it. So So this hold on statement basically allows this particular plot to overlap on the previous one, and I'm giving it the color code green so that this signifies all the original data sets. After we are done with this, I will end this for loop and I will give the one final plot that I want to see, which is the mean template. Mean template. And this I will give the color code of blue perhaps. And once this is done, I'll just quickly copy paste this label, Control C and V. So over here, you can see how our template changes as compared to the original plot. This is the result of synchronized averaging. Thank you for watching.